So we've learned that Couchbase exposes 5 services through a single node type, and you can scale these services independently. But what also matters is how well we deliver data back to you when you need it. So let's dig further into the services themselves. So we've learned how Couchbase keeps your data documents in buckets on nodes in clusters. There are 5 different ways to get it back. First, through the data service, we support key value operations. Our SDKs expose get, insert, upsert, replace, and remove operations for documents and subdocuments, along with a data structures API if you'd like a clean layer of abstraction. Second, also through the data service, we provide the ability to create aggregate views generated by distributed MapReduce style functions. Third, through the query service, we support select, insert, update, delete, join, where, having, group by, and much more that you'll find very familiar, along with a robust function library. This service relies in turn on both the index and data services to efficiently deliver your query results. Fourth, the full-text search service maintains inverted indexes and provides tokenization, stemming, faceting, relevancy scores, and more in support of natural language queries, with results delivered directly from your data buckets, not some remote system out on the network. And fifth, the analytics service provides continuous distributed isolated queries to support ongoing analysis of the data you already have there right on board in your data buckets. Now let's drill in a bit. The data service itself has 5 key components. First, a managed cache, because memory-first architecture is directly in our DNA as a product. Second, storage. Third, a persistence queue to flow data from cache to storage. Fourth, an in-cluster replication queue to support high availability by moving replicas onto other nodes. And fifth, a cross-data center replication queue to support high availability, disaster recovery, and filtered distribution scenarios. All of these queues rely on robust shared multi-thread pools. We'll talk about those more in a moment. Now, Couchbase is memory first on all fronts. Key value operations are served from the cache first. And they only seek on disk if there's a cache miss, after which the missed doc is then cached. The cache is managed based on most recent document use, and cache ejection can be tuned for either full ejection, which means a subsequent cache miss requires a disk seek, or value-only ejection, which leaves keys in cache and only ejects the values. Which is best depends on key size, data volume, application demands, and similar factors. Now let's take a look at how documents flow throughout your clusters. Imagine you have 2 clusters. For simplicity, imagine a 2-node cluster in London and a 1-node cluster in Tokyo, though you'd very likely have more nodes than this. Your application creates a document and hands it to the Couchbase SDK. The SDK passes that document to the cache of an appropriate node in your target cluster. From the cache, at least in this scenario, which assumes configuration for both in-cluster and cross-data center replication, the document then enters the persistence queue for local storage. It also enters the in-cluster replication queue for memory-to-memory transmission to another node in the same cluster, where it is also cached, and then passed to that node's persistence queue to be stored, though this time as a replica. And the document also enters the XDCR, or cross-data center replication queue, to be filtered and passed, memory-to-memory, to a node of the remote cluster, where it is also cached and passed along for storage. Now, all replication in Couchbase, whether for local persistence, in-cluster replication, or cross-data center replication, relies on the Database Change Protocol, or DCP. Now, this protocol provides for no-loss recovery on interruption, RAM-to-RAM streaming, and multi-threaded parallel processing. Next, let's look at aggregate views a bit. Aggregate views are a traditional way in Couchbase to aggregate data using distributed MapReduce style functions. With this feature, mapping functions are defined and distributed among all data service nodes. they process each document on that node to generate a secondary index. The emit functions specify the key and value for each corresponding entry to that index. These indexes are available via REST API, and query parameters are available to filter the results. The functions run on each data service node inside a V8 JavaScript engine. That's the same engine that processes Node.js, if you're familiar with that. And these are efficient for ongoing statistical evaluations, like counts and summations. Next, let's look at NCL queries. So NCL queries are SQL for JSON, Structured Query Language, SQL, however you prefer to pronounce that. It gives you the familiarity of SQL, coupled with the flexibility and scalability of JSON-based data models. So a NCL query looks very much like a SQL query. The difference is that you're querying document attributes within a bucket instead of columns in a table. You have all the filtering power that you expect from SQL, along with aggregations, functions, as well as new behaviors that are specific to JSON, such as nesting and unnesting multidimensional data within documents. A query might look like this. Give me 3 attributes from my customer documents where year-to-date sales are filtered within a range, and then order the results by name. Of course, while ad hoc querying is supported just as with any database, you'd want to create appropriate indexes to optimize the speed of your commonly used queries. As you can see, the way you do it is easy and familiar to anyone used to working with SQL. The resulting indexes are maintained, lock-free, and fully in memory if you choose, by the index service. Now, if you'd like to know more about this right away, take our free online course, CB110, Intro to the NCL Query Language. Now let's take a look a bit at how NCL queries operate. First, your application passes a NCL query to the cluster through the SDK. The query service parses the query, analyzes it, and plans the execution. The query service then requests an index from the index service. Now this may be a primary index put in place to support ad hoc querying during development, or more likely a secondary index specifically designed for this query. The index service responds to the query with relevant document IDs and any other indexed data. Now, if needed, the query service then fetches additional unindexed data from the document IDs provided by the index. Now, this fetch process is skipped if the query is covered, meaning all requested attributes in the query were already included in the corresponding index. The query service then formats the results with ordering, grouping, functions, and so on, and then returns the results to the client. Now, while this may be obvious, just to be clear, all this is happening among all nodes exposing the query index and data services, not on any one single node. Now let's take a look at full-text search. Users understand full-text search, and it's Google, and they want it. It's that simple. But why spread text all over your data center just to meet the demand for a search box and related behaviors? Couchbase full-text search, which is based on the open-source Blevy search engine, gives you natural language query capability for the documents that you've already got in your buckets. We provide multilingual and custom text analysis on both the search and indexing sides. We support industry-standard TF-IDF term scoring and result highlighting, as well as faceting by term or numeric or date range. You can search by required, optional, or boosted terms, phrases, and prefixes, as well as common word stems. You can run compound, conjunction, disjunction, Boolean, and date range queries. All this, and your documents never need to leave your database. So what have we learned here? Well, Couchbase is blisteringly fast because key-value operations are served directly from cache, managed by use and ejection type. Documents are persisted and replicated via multi-threaded RAM-to-RAM queues running the durable DCP protocol. The query service gives you NCL, which is SQL for JSON. The index service optimizes performance through covered indexes and other features. The search service gives you natural language search capability without having to move your documents, and aggregate views expose statistical indexes via REST. As you can see here, the data service and buckets have a lot to do with how Couchbase behaves. So in the next lesson, we're going to dive deeper into how buckets operate. Come on back.